Assalamualaikum warahmatullah. Okay, today we're going to continue with the next topic, which is sampling. Okay. Okay. Talk about sampling. We are talking about choosing portion the population to be representative of the study. Okay. So you need to ask the question: who do you want to generalize to? What population can you generalize to, and how can you get them in your study? Right. So once you've identified this type of questions, only then you can determine your sample size, right? A statistical inference permits us to draw a conclusion about a population based on a sample. Okay. Sampling is often done for two reasons. Once, because of cost. It is less expensive to sample 1,000 TV as compared to 100 million TV viewers. Okay. The second reason is because of practicality. I mean, who in their logical mind would want to interview or survey 100 million TV viewers in Malaysia? Malaysia population dia tak sampai 1,000, cuma 20-30 ribu lah. Tapi logik lah, you kena tanya diri you. Untuk you nak hantar survey ke semua 20-30 ribu just to get an idea what type of TV program they like to watch. Okay, so you must consider the practicality of how you're gonna do the survey. Misalnya, okay, let's take a more logical amount, not 1,000, katakan 100. Maybe dalam sebulan tu minggu pertama, katakan you want to do research relating to what people in Kuala Nerus watch. So mungkin you ada target lah. Minggu pertama you survey atau interview orang Batu Rakit. Kedua, you pergilah ke Wakaf Tengah. Ketiga, Seberang Takir. So 100 orang and you dah dapat frame dah tempoh masa yang you akan do the survey tu. So the action that you take shows the practicality in doing it. Okay lah. Generally, there are two types of sampling. One is the probability sampling, in which element of the population have a known chance of being chosen as a subject. And the second one is non-probability, meaning the elements in which does not have any probability of being chosen. Okay, the first one is probability sampling. And the first one is simple random sampling. For example, in a restaurant manager has been asked to consider formulating flexible working time policy. 1,000 elements in the population, and you need a sample of 100. So dia ada 1,000 staff, tapi dia perlu 100 staff dia dalam survey dia. So maknanya 1,000 chance of 100 times for someone to be selected. Okay, di kata lain, simple random sampling, you boleh bayangkan cabutan bertuah lah. Kalau analogi yang paling mudah untuk gambarkan simple random sampling ni. Okay, you ada 1,000 orang, tapi you nak 100 orang. So you tulis nama ataupun letak special ID lah. Cabut nombor 1 Ahmad, nombor 2 Siti, nombor 3 Acong, nombor 4 David. That is one example of easy example of how simple random sampling works, ya. Bayangkan buat cabutan bertuah, pilih orang-orang yang bertuah untuk join survey you lah. Okay. Okay, the second form of probability sampling is called the stratified random sampling. stratas or subgroups that you've chosen for this study. So, kat sini dia kata HR director is interested in assessing extent of training the employee in the system feel need. So, dan HR director ni dia nak buat penilaian training efek keberkesanan training terhadap employees yang ada dalam restoran tu. Strata yang bawah mungkin mewakili waiters, cashiers, meaning the operation staff. Dia yang tengah, strata yang tengah mungkin representative of middle managers, supervisors, supervisors. Top tier may be representing managers in the restaurant. General manager, mungkin dia assistant manager, purchasing manager. Okay. Setiap segmen employees ni memerlukan training ataupun perlu dinilai semula training yang diberi ni berbeza. Kan waiters ni training dia perlu lebih kepada technique of service, how to properly use the POS system, how to professionally take order using style, how to effectively deliver American, Russian of service. Okay. Right, pada dia yang tengah, supervisor atau assistant supervisor, mungkin penilaian dia berkaitan dengan kemahirannya untuk buat penjadualan. Supervise ni dia ada advance sikit, dia punya skill ni lebih kepada beverage preparing beverage, alcoholic or non alcoholic beverages. Okay. Apa lagi? Mungkin the middle managers ni perlu ada knowledge on how to handle guest feedback or guest complaint. Okay. Pada top managers pula, training ataupun knowledge yang perlu di-evaluate ialah berkaitan dengan knowledge menu planning, costing of menu, store plan, and costing of sales. Okay. So, setiap peringkat tu perlu ada parameters of information yang berbeza untuk dinilai. Okay. That's how strata sampling is being done, and based on the example of hierarchy position in the restaurant, setiap peringkat employees tu dinilai cara berbeza tentang training yang diorang lalui. Staff mungkin diuji tentang operation, middle dan upper management, dan upper management staff mungkin dinilai berkenaan dengan management skills and costing. Okay. Third example of problem sampling is called systematic random sampling. Okay. Beza dengan simple random, systematic random sampling ni dia buat randomization dalam banyak peringkat, okay, ataupun jelasan yang lebih mudah. Jom kita tengok video yang saya sediakan dalam link YouTube ni ya.
Which we've already talked about in other videos. And we're going to compare what we already know about simple random sampling to a new type of random sampling that we're going to introduce in this video, and that is systematic random sampling. So let's look at an example. Let's say that there is a concert that is happening, and we expect approximately 10,000 people to attend the concert. And we want to randomly sample people at the concert. Maybe we want to do a study on how do people get to the concert? How do people get to the concert? Do they drive and park? Do they ride with a friend? Do they take an Uber or a cab of some kind? And so we want to find a random sample, ideally without bias, to survey people. So there's a couple of ways you could do it. You could try to do a simple random sample. And that might be a case of if you could somehow get the names of all 10,000 people and put them into a big bowl like this. And then let's say you want to sample 100 people. Let's say you want to sample approximately 100 people. You could just mix up all the names that maybe are on these little pieces of paper, 10,000 of them, and then pull them out and pull out a random sample of 100 of them. That would be a simple random sample. But you could already imagine there might be some logistic difficulties of doing this. How are you going to get the 10,000 names? You're going to write them on a piece of paper. That's going to be you'd have to really mix them good so it's truly random who you're picking out. So are there other ways of doing a random sample? And as you can imagine, yes, there are. And that's where systematic random sampling is useful. One way to think about systematic random sampling is you're going to randomly sample a subset of the people who are maybe walking into the concert. So let's say people get to the concert and they start forming a line to get into the concert. What you want to do in systematic random sampling is randomly pick your first person. There's a bunch of ways that you could do that. Let's say you have a random number generator that'll generate a number from 1 to 100, and that's going to be the first person you survey. If that random number generator generates a 37, then you're going to start with the 37th person in line. So you pick that first person randomly, you survey them.
Okay, we start dengan the first respondent secara randomly, can be number 30 ataupun 3, doesn't matter.
And remember, our goal is to sample about 100 people out of 10,000. So we want to roughly sample 1 out of every 100 people. And so what you do there is
So dia nak cuba samplekan satu dari bagi setiap 100 um, 100 penonton yang datang ke konsert tu lah. Okay, so that's why dia kena pilih responder dia berperingkat demi peringkat.
once you have that first person that you're sampling, you then sample every 100th person after that. That's called sometimes the sample interval. And the reason why 100 people is
Okay, the keywords dia for the next responder number 2, number 3 is intervals, meaning dari responder pertama ke responder kedua mungkin selang 100 atau selang 200.
because if you sample every 100th person after that, you're going to roughly get 100 people in your sample out of a total of 10,000. So this is going to be after 100, you're going to sample someone else. And then after another 100, you're going to sample someone else. Now, the reason why this is useful is you could say, okay, that first person was random, and then every person after that, it doesn't seem like there'd be any bias for why they would be the 100th person after that first person. You don't want to just do the first 100 people because those might be the early birds, the people who maybe disproportionately went parking or planned early or had some bias in some way. So you do want to make sure that you're getting both the beginning, the middle, and the end of the line, which this thing helps. Now, we have to be careful. Even systematic random sampling is not foolproof. There's a situation where inadvertently even this system has bias.
Okay, dia kata the system ni not foolproof and kemungkinan bias tu tetap ada.
Let's say that this is the arena. This is a top view of the arena right over here. And this is the line of people coming in. And this is where you are standing and you are counting every 100th person. But maybe, and let's say there's a tree right over here, and maybe there's a road. I'm making this quite elaborate. So maybe there's a road right over here. And a lot of people, maybe all of the people who are walking or taking a cab are coming from this direction. And maybe all of the people from the parking lot are coming from this direction. And maybe you have a police officer right over here who is doing crowd control, who lets 50 of these people in, followed by 50 of these people in. Well, in that situation, every 100th, you might end up just sampling one side or the other. So you have to make sure that there isn't some bias that's being in.
Okay, dia kata based on the scenario ni, kemungkinan you akan dapat 100 orang tu daripada kelompok yang sama saja. Mungkin 100 orang tu 100% daripada yang dah beratur, 100% daripada yang parking, ataupun 100% tu datang daripada yang naik taksi. So benda-benda ni yang researcher ni pesan, cuba sedari upaya untuk elakkan so that your sample does not become biased. Okay. Right. So the next type is cluster random sampling. Kalau by definition cluster ni adalah kelompok sampel yang kita pilih untuk represent population. Okay. Biasanya popular kalau you nak buat study ni as a nationwide or a continent-wide study. Okay, so mungkin saya bagi contoh nationwide study ya, 13 negeri, and katakan research kita ialah kita nak tahu the knowledge of GMP and HACCP di kalangan managers kilang keropok leko. Okay lah. So di Terengganu kita buat pembacaan, literature review, dan kita dapati daripada 8 daerah ni banyakkannya tertumpu pada Setiu berbanding Kuala Terengganu, Kuala Nerus ataupun Besut. So ikut rule ni disebabkan Setiu mempunyai konsentrasi kilang keropok leko yang paling banyak. So kilang-kilang keropok leko tak kisahlah 30 ke 40 atau 400 sekalipun, meaning state of Terengganu akan diwakili kilang-kilang keropok leko yang berada di Setiu. Meaning kita tak perlu masukkan representatif daripada Besut ke, daripada Kemaman ke, daripada Marang ke. Okay, kita pilih yang majority. Okay, kalau kita pergi ke negeri lain pula, misalnya mana? Okay, kita ambil Penang. Okay, Penang dia punya kawasan perindustrian dia bukannya kat Georgetown, dia punya industrial area is actually Perai. So mungkin you buat pembacaan and you dapati keropok leko di Penang tertempu di Perai. So you ambil lah an amount of keropok leko factories, managers di Perai. So kelompok kilang keropok leko di Perai itu mewakili Pulau Pinang. Di Selangor, mungkin dia punya kilang paling banyak ialah di Sabak Bernam, bukannya di Shah Alam, bukannya di Petaling Jaya. So Sabak Bernam dipilih untuk mewakili Selangor. Okay. And the list goes on. So cluster sample, kita pilih kelompok subpopulation yang paling signifikan untuk mewakili sesuatu negeri ataupun kawasan tu in a nationwide or statewide study. Okay. Right. Now we move on to what is non-probability sampling. The first one is convenience sampling. So in layman's term, kalau kita tengok convenience tu benda yang senang lah. Meaning kita ambil responden yang sedia ada. Sebagai contoh, katakan you develop durian flavored Pepsi Cola contohlah, and you nak buat, you nak just nak dapat apa, feedback satisfaction or acceptance of this durian flavored cola. So you pilih lah untuk buat you punya small survey ni dekat misalnya Giant Kuala Terengganu. So you set up booth, you set masa survey ni akan dibuat daripada pukul 10 pagi hingga 4 petang, dan target you ialah 200 orang pelanggan. So siapa-siapa yang lalang di booth you dari pukul 10 hingga 2 petang tu, dialah yang you akan pilih. Okay. Dia ada tapisan apa, nak tahu dia ni peminum cola atau tak, cola dia lelaki ke perempuan, dia menetap di Kuala Terengganu ataupun so siapa yang ada, you rembat saja. That is the example of convenience sampling lah. Second type is called non-probability sampling, is the quota sampling. Okay, maybe you dah set you perlu 200 orang untuk survey you, and survey you ialah berkenaan nak tengok purchase pattern of football fans apabila tengok live match, live home match diorang. Okay, nak tengok bagaimana purchase pattern antara misalnya peminat bola Liverpool lawan versus peminat bola Manchester United. Okay, Nyonya nak buat kajian lah, nak tengok adakah penyokong Liverpool ni cenderung nak beli hotdog, ataupun adakah penyokong Manchester United ni lebih cenderung nak beli air jus pembaling air cola. Okay, so you set lah maybe 100, okay, daripada 200, 100 you setkan untuk penyokong Liverpool, 100 lagi you setkan untuk mewakili penyokong Manchester United. Okay, it can be of equal proportion or slightly ataupun contoh kedua, mungkin you dapati penyokong Liverpool ni disebabkan populasi bandar Liverpool tu boleh lebih besar daripada Manchester, mungkin you boleh set lah misalnya berapa 200 tu 110 you pilih untuk mewakili Liverpool, tetapi 90 saja mewakili Manchester United. Okay, ini you buat justifikasi itu sebab atas dasar bandar Liverpool tu lebih banyak daripada banyak penduduk berbanding Manchester. Okay, ataupun kalau you nak buat male dan female, kalau you tak nak buat 50-50, you buat 60 male 40 female, mungkin you boleh bagi justifikasi lah. There are more male football fans that eat during live match as compared to female. Okay, so quota sampling kita setkan satu kluster tu berapa banyak percentage or berapa banyak responden yang you kena ambil. Apabila you hit maximum, you tak boleh ambil lebih dah. Okay. Next type of non-proprietary sampling is called the snowball sampling. Okay. Kalau tak dapat lagi experience negara salji, tak apa, jangan hati-hati. Saya pun tak pernah experience snowball ni. But the principle with snowball, you roll daripada kecil, push in a straight line, and dia akan jadi snowball yang gigantic ni lah. Okay. Dan konsep snowball sampling ni diguna pakai sekiranya your subject is hard to trace or your research topic involve sensitive issues. Kalau dia kata sini, katalah or illegal immigrants ataupun melibatkan criminals. Okay. So saya bagi contoh, you nak buat kajian tentang aktiviti penyeludupan beras di Padang Besar, Perlis dan juga Hadnyai. Tahu you nak ambil smugglers tu sebagai responden you will put yourself at a very big risk. Silap-silap dia pergi kepada smuggler yang you dah identify tu, dia hulur pisau depan mata you and will lose your life. So for subject matters or topic of controversial ni, biasanya guna approach snowball ni lah. So if you cannot approach those criminals, those smugglers, those big boss ni, macam mana you nak dapat maklumat tentang aktiviti penyelundupan ni? So maybe you need to take a step back. So you ask yourself, penyelundup ni siapa yang ada direct knowledge or in contact of chasing them, tracing them after this? First party yang mungkin you boleh approach for data information, whether it's a survey or interview, it's the police. So dapatlah maklumat. Polis setiap tahun buat roadblock di area mana dalam tempoh berapa jam, dan selalunya dapat dikesan smugglers ni menggunakan kaedah apa? Adakah diorang ni lebih aktif waktu malam berbanding waktu pagi? Jenis kenderaan yang diorang guna, dan bus grade apa yang diorang selalu keluar dan masuk sepadan ni. apabila you uh, get the ball rolling di peringkat polis, mungkin you nak go on to jabatan custom. So dapat maklumat daripada custom pula lah berapa amount yang rugi hasil penyelundupan ni. And kita tanya juga custom ni macam mana operasi dia. Kalau tak di laluan utama, adakah dia pasang juga ataupun dia have agents undercovering and infiltrate di smuggling ring ni. Okay? Yang biasanya berapa lama. Okay? Dan apabila berjaya tangkap dan ni, berapa lama prosedur untuk takwaan and sabitkan kesalahan. Okay? So that's the second role ataupun second lapisan of respondent. Yang ketiga, mungkin you nak approach penduduk yang tinggal di sempadan Perlis dan Thailand tu lah. So ada satu kampung, kita tanyalah, jual pakcik-makcik rasa selamat ke tinggal sini dengan aktiviti kehidupan? Adakah pakcik-makcik ni selesa dengan polis dan custom sentiasa around area kampung pakcik-makcik ni? Ataupun adakah pakcik ada pengalaman di Ubud ataupun digula-gulakan oleh penyelundup ni untuk sorok beras dalam reban ayam ataupun dalam belakang kereta dan minta pakcik-makcik ni rentas sempadan dan pergi ke lokasi tertentu dan keluarkan beras tu pada orang yang berada di Thailand. Okay, so makcik di kampung tu akan ceritalah dalam mereka rasa terancam ke semacam zaman darurat, tak boleh keluar lepas pukul 6, pukul 7 ke. Okay, and they feel the authorities are doing enough to stop smuggling or not. Okay, stuff like that. So pastikan dari peringkat pertama, polis, custom dan juga penduduk kampung. Polis mungkin you dapat 20 respondent. Custom you get another 20 respondent. And daripada penduduk kampung kan 30. 20 plus 30 dapatlah dalam 20 respondent. So setiap peringkat you lalui ni, sampling you akan bertambah and your data will get will be more rich lah apabila you lakukan survey atau tinjauan tu berperingkat-peringkat. Dan snowball sampling, saya teringat masa buat PhD dan kat awal lah, banyak macam-macam bengkel kita orang hadiri. Salah seorang tu dia buat pasal Money Trail 1MDB, quite a controversial topic at the time lah. Okay. But true to the concept of snowball sampling ni, dia tak boleh lah approach the CEO of 1MDB or certain individu yang dituduh menerima wang yang banyak dari luar negara tu. So what she did at the time was go through different stages lah. Dia kena pergi Jabatan Audit Negara, tanya forensic accountant, dia kena tanya lawyer tentang akta-akta keuangan ni, macam mana berlaku kalau jumlah ni masuk ke dalam akaun ni, kena declare ke, kalau tak declare apa sebenarnya implicationnya. Okay. Right. So that is how snowball sampling works. Yeah, if you are doing research, if the subjects is difficult to trace, or the topic involves a high risk, or such as criminal activities or smuggling activities. Right? So you may ask your future supervisors or lecturers, selalunya berapa banyak ya itu cukup? Okay. Generally, the bigger the better. Saya pasti, saya rasa dengan Dr. Asmah, you dah lalui dah atau didedahkanlah berapa teknik untuk mengira sampling based on valence. Okay. But social science, kalau kita tak ada data berkaitan dengan satu population, we can use a general rule of thumb. Okay. So first popular rule of thumb dalam social science ni pertama ialah Roscoe 1975. So what Roscoe said is n more than 30 or less than 50 is appropriate for most research. Okay. You have some samples, maybe male or female, orang Kelantan, Terengganu, Sabah, Sarawak. Usually, Roscoe recommend at least 30 people to represent for this subgroup of categories. Multivariate analysis, n should be several times, preferably 10 times more as large as the number of variables in the study. So kalau nak buat multivariate research, kalau you ada 6 variables, independent variable masuk, termasuk moderating, mediating dan juga dependent variables tu ada 6 kali 10, you kena ada at least 60 responder lah. If you have more, the better. If you do simple experiment research with tight experiment control, you can get away with about 20 to 10 to 20 sample size population. Okay. Another commonly quoted researcher in social science is punya rule of thumb of sampling. Tengok dia bagikan national wide study or a regional statewide or city wide study, macam mana? Okay. Dia kata kat sini, andai kata study tu tidak melibatkan apa-apa subgroup, lelaki, perempuan ke, Chinese, Malay, Chinese, Indian, Melanau, Kadazan Dusun ke, meaning kajian tu ialah melibatkan Malaysians. On a national level, cukup sekitar 1,000 hingga 1,500. Dia kata study you melibatkan banyak sub-ethnic group, mungkin you patut consider between 1,500 to 2,500. You're doing study ni peringkat negeri, peringkat daerah, sekitar 200 hingga 500 cukup kalau tak melibatkan banyak subgroup. Saya kata you ada banyak subgroup, mungkin you patut consider population antara 5,000 hingga 500 hingga 100 hingga 1,000. Okay. So rule of thumb biasanya Roscoe dan Sutman lah yang paling banyak diikutkan ataupun dijadikan garis panduan. Right? Other factors for you to consider when choosing your sample size. First of all, is the degree of precision required between the sample and population. It is less precise when you do a small population. Variability of the population. If a population is more homogeneous, population requires smaller samples. Method of sampling, a stratified sample requires fewer cases. Way in which result will be analyzed. Smaller samples put limits on types of analysis possible. Selalunya yang boleh saya kongsi kat sini, kalau kuantitatif bolehlah you target above 50, 100, 200 ke atas. Tapi kalau kualitatif, biasanya kita tak target sampai 100, 200 tu. Biasanya orang target di antara 5, 10, 30 atau pun 50. Jarang-jarang sekali orang buat qualitative study melibatkan beratus-ratus orang. Okay. So when you do sampling, there tends to be a scenario where you might have the errors lah. Okay, how sampling error is how close the sample size is to the size, or how well a sample of the size meets a given population. Okay. Sampling error is the standard deviation of a sample distribution is referred to as the standard errors. Or however, if your sample size is bigger, the smaller the chance of that standard error occurs, and this is because the greater sample size, the closer it is to the actual population itself. All right. Second type of error that can occur is non-sampling error. Okay, sampling error ni berkaitan dengan jumlah population. Non-sampling error dia ada 3 jenis. Secara ringkas, dia ada errors in data acquisition, non-response data, and selection bias. Tahu lebih lanjut, saya akan buka link video YouTube yang slide ni.
Describe the concept of sampling variation, which is also called sampling error, and how it is related to sample size. The research question we'll be thinking about is how far people walk each week. If we think about the entire population, it should be the case that everybody doesn't walk the same number of steps each week. That is, maybe this person takes 56,932 steps in a week, and this person takes 62,157, and this person only takes 49,238 steps, and so on. What we're seeing here is a type of variation called natural variation, the tendency of individuals within a population to have different values of a variable. And when we take a sample from the population, we can see this natural variation from the population also appearing in the sample. And we can estimate this natural variation using measures like the standard deviation or interquartile range. Now, there is another type of variation that is important in statistics. In our sample, we can compute a statistic such as the sample mean. Pause the video for a moment and think about the following question. Is this sample mean equal to the population mean? The answer is, well, we don't know. Because we don't know what the population mean is. We don't have data from the entire population. But it seems unlikely that this sample mean would be exactly the same as the population mean. And this phenomenon is called sampling error, because the sample statistic is not equal to the population parameter. Let's go back to the population and think about this a bit. What if, instead of our original sample, we had randomly selected a different group of 10 people? And we collected data from everyone in the sample, then looked at the distribution of these data, which would again be a distribution of a sample, and would have its own sample mean. And if we think again about the entire population, we can see that there are many, many possible samples of 10 people we could have randomly selected from the population. And because there is natural variation in the population, each sample will have a slightly different sample mean. Then we could think of the collection of sample means as a set of data itself. And we could look at the distribution of these sample means as a histogram. So each data point in this histogram is a different mean from a 10-person sample. And we can see that different samples have different sample means. This type of variation is called sampling variation, which is the tendency for different samples from the same population to produce different statistics. Sampling variation is produced by a combination of natural variation in the population and the random aspect of the sampling process. And much like the way we measure natural variation using the idea of standard deviation, we measure the amount of sampling variation using something called standard error, which is the standard deviation of the sampling distribution. You might be wondering whether you can avoid sampling variation. Alas, the answer is no. As long as there is natural variation in the population and you're taking a sample using a random process, then there will be sampling variation. But you can reduce the amount of
Tapi boleh dikurangkan. Dihapuskan tak boleh, tapi dikurangkan boleh.
Sampling variation. Let's think about how to do this. So here is our original 10-person sample. Assuming we used a good sampling method, the mean in this sample will be reasonably close to the mean of the population. But now imagine that we randomly selected 20 people for our sample instead of 10. Since our sample is larger, it should do a better job reflecting the natural variation that is present in the population.
So, seperti mana yang ada dekat the slide, untuk kurangkan sampling error dengan mengambil jumlah sample size yang lebih besar, in this case daripada 10 ambil 20, the tendency to have sampling error tu akan dikurangkan.
Consequently, the mean of a larger sample will be closer to the population mean.
Larger portion will be closer to the
Let's think about how this impacts sampling variation. Now, instead of 10-person means, we're going to take samples of size 20 and compute a mean for each sample. And each of these sample means will be closer to the population mean and, therefore, to each other, which reduces the amount of sampling variation. Now, let's recap what we've seen here. We looked at the concept of natural variation among individuals in a population and saw how the combination of natural variation and sampling produced sampling variation. Sampling variation is measured by standard error. And finally, we saw how increasing the sample size reduces sampling variation, and thus the standard error.
So that's standard error. Now let's look at the video. Okay, the next video relating to non-sampling error.
Sampling errors. So what we want to do here is think about our key idea. And the key idea is that we want data that is representative. So I want, if I'm interested in teenagers, I want a mixture of ages, genders, ethnicities, hair colors, device types, family incomes, you name it. I want a mixture of all of those so that my data is representative. Okay, so there's two ways that we can take a sample. One of those ways is by taking a random sample. The other is by taking a biased sample. So if we take a random sample, that means everybody has the same chance of being chosen, whereas the biased sample is not. Some people will be chosen and others won't, but the probability that being chosen is different. So if I was to choose just the students sitting nearby, then that would be a biased sample, and only those that are sitting nearby have any chance of being chosen, and others sitting further away have no chance of being chosen. So here's an example of what a biased versus representative selection of lollies would be. A bias means they're all jelly beans, okay? They're all similar in some way. Whereas representative means there's a mixture of different lolly types, different colors, different sizes, different flavors.
Okay, yang contoh lollipop gula-gula ni, jelly beans ni adalah contoh in data acquisition. Okay. Okay, data error in data acquisition ni merujuk kepada incorrect measures being taken to measure a phenomenon. Okay, you nak measure eating preferences of sweets among primary school student. Tapi benda yang sepatutnya you nilai tu ialah sweets, gula-gula lah. Tak kisahlah jelly beans ke, candy cane ke, gula-gula hex ke. Okay, kalau error in data acquisition tu berlaku, mungkin, okay, contoh yang saya bagi, you masukkan penilaian atau parameter yang tak sepatutnya you masukkan. Misalnya, you masukkan coklat Cadbury, you masukkan air hot chocolate, you masukkan air peach tea, which does not even relate to gula-gula or sweets at all. Okay, so that is inaccurate way of measurement. Okay, all right.
all of those things. So if I want to be randomly choosing them, I will get a mixture of characteristics. So things like different genders, ages, boarding preferences, ethnicities, cultures, family type, you name it. Everything that makes us who we are will be completely mixed with a random sample.
Okay, so second type of error that can occur be related to selection bias. Okay, katakan contoh tadi, preference of sweets um, among primary school children. Kalau primary school di Malaysia, by definition, siapa-siapa lelaki atau perempuan, apa saja bangsa, age group between 7 hingga 12 tahun. Anything after that tak dikira primary school student lah. Okay, but akan jadi bias in terms of sampling apabila you dalam kelompok primary school student tu you hanya tumpu kepada darjah 1 saja atau tumpu kepada darjah 6 saja. Ya, diorang ni ialah primary school student by definition, tetapi since you tumpu pada satu kelompok saja, you tak peduli darjah 5, darjah 4, darjah 3, you dah kira sampling bias dah di situ. Okay?
So for an example, if I'm doing a questionnaire
Selection
with
bias
only
namanya.
blue-eyed students, that means that I've only got information about people that have got blue colour eyes. I don't have any information about anyone else with any other eye colour. So that means my data does not represent all people, it only represents people with blue eyes. Okay, so let's have a look at this exercise. So OEC has about 650 students. Students want to do a survey.
So saya stop di sini saja. Okay. So the third example will be non-response error. Okay. Non-response error ni merujuk kepada you includekan responden yang luar daripada target market atau target responden you. Misalnya, okay, sepatutnya kajian you hanya melibatkan sekolah rendah primary school student, tetapi you buat kesilapan dan you include student dari sekolah menengah, student yang baru masuk uni ke dalam study you tentang preference of sweets tu. So ini sikit sebanyak telah cacatkanlah you punya sampling ni, and you dapat data yang not representative since you dah masukkan sekolah menengah dan juga orang student universiti ke dalam mix of sample, campur sekali dengan budak-budak sekolah rendah tu. So from there it's a non-response error, ya. Okay. So sum it up, non-sampling ni ada 3. First, the error through data acquisition, meaning dalam contoh gula tadi, ada items, you ada parameters untuk nilai gula-gula, tetapi you terlebih gairah you masukkan items ataupun parameters untuk menguji coklat dan juga minuman manis. Okay, so ini menyebabkan error dalam data acquisition you. Itu ialah selection bias, di mana patutnya you ambil sampling secara rawak dan balance di kalangan semua pelajar sekolah rendah. Tapi kata untuk jimat masa sebab nak cepat, you ambil darjah 6 saja and you tak peduli darjah 1 sampai darjah 5. Bila you buat macam tu, you dah melakukan selection bias di situ. Darjah 6 tu ialah sekolah rendah, tapi you punya data tu berat sebelah cenderung kepada budak-budak darjah 6 sajalah. So it's hard for you generalize for whole population of pelajar sekolah rendah. Last sekali, non-response error, di mana ambil sampling berdasarkan sekolah rendah, tetapi kajian gula-gula tu you lebih gairah you pergi jemput ataupun minta pelajar sekolah menengah dan pelajar universiti untuk sama-sama join untuk survey preference of gula-gula ni. So that creates the non-response error, daripada meaning you ambil orang yang tak sepatutnya participate dalam study tu untuk participate dalam study tu. Okay, right, so those are types of errors that can occur, sampling and non-sampling error. And non-sampling errors ni di highlight ni adalah more severe compared to the sampling error, and very hard to overcome kalau you tak very hard to fix if you baru sedar dia at a later stage of your study. Sepatutnya you dah awal-awal dah clear dah you punya operational definition, switch tu apa, and what is your definition of primary school students, sepatutnya dari age 7 hingga 12, darjah 1 hingga darjah 6. Okay, you have to be clear from the beginning of your definition of parameters and and who you want to respond to in order to avoid non-sampling errors. Okay, right, so that will be it for this lesson relating to thing. Allah, 14th week, we'll continue on with questionnaire development dan juga pilot study as well as questionnaires. Okay, see you next week. Assalamualaikum warahmatullahi wabarakatuh.